in each term?
It's multiplying itself.
Being multiplied by 2 each time, okay? It can also be so this would be multiply times 2, or we can kind of have it go the other way and have something more like, what would you have to do here to go from one term to the divide by 2? Except when we talk about this, we're not going to think about it as a dividing by 2. We're going to think of it as multiplying by 1/2. Okay, just because we want it to have a constant number that gets multiplied each time. Okay, because that's the key part of having a geometric sequence. So a geometric sequence, okay, is a sequence in which the ratio remains constant throughout the entire sequence. So it is a sequence of numbers in which the ratio remains constant. And to find the common ratio, so it is found by dividing each term by its previous term. So if we look at that example I just did here, we would find it by doing 4 divided by 2 to get 2, and 50 divided by 100, which is 1/2, okay? So a trick to use so that you always get the fractional answer for that is whenever you do it, put it in your calculator as the fraction. So use the fraction key and do 50 over 100, and it will simplify the fraction for you automatically, okay? Do that so that way, because if you answer with decimals, because of rounding, it sometimes makes the answer not correct. Because there's a difference in 1/3 and 0.33, because 1/3 is actually 0.333333333333. You get the picture, okay? So it makes it a little bit different. Did you have a question, Connor? Did you? Oh, okay. Now, we're going to start with identifying whether or not they are geometric sequences or not. So we're going to look at number 1. So to do this, what is 10 divided by 2? What is 50 divided by 10? What is 250 divided by 50? So is that a geometric sequence? Okay, and the common ratio is 5. All right, for number 2, what is 45 divided by 135? Remember, like I said, put that in your calculator as 45 over 135 and tell me what it simplifies to. 1/3. Okay. Same thing, what is 15 divided by 45?
1/3.
5 divided by 15? 1/3. So, is that a geometric sequence?
Yes.
What is our common ratio? All right, now, for number 3, what is 18 divided by 6?
3.
What is 24 divided by 18?
2/3.
It's not 3, right? Does it really matter what it is if it's not 3? And I think it's like 1.3.
This is 4 over 3.
4 over 3? No. Okay, so they are not the same. So are those a geometric sequence?
No.
Okay, now, for number 4, what is negative 14 divided by 7? What is 28 divided by negative 14? Negative 56 divided by positive 28? So is that a geometric sequence? What is our common ratio? Okay, for number 5, what is negative 40 divided by 80? Negative 1/2. What is 20 divided by negative 40? What is negative 10 divided by 20? So is that a geometric sequence? Okay, and what is the common ratio? Okay, so for number 6, What is 36 divided by negative 36 divided by negative 9? What is negative 144 divided by negative 36? Also 4. What is negative 576 divided by negative 144?
Maybe 4.
So is that a geometric sequence?
Yes.
Okay. And what is our ratio?
4.
All right. So whenever it asks you to determine whether or not it is a geometric sequence, you need to check all the terms because the problem could happen in any of them. Okay. Now, we're going to go ahead and we're going to look at the second section. So the second section just wants us to continue our geometric sequences. Okay. So it just wants us to keep the trend of multiplying it to find the next 3 terms. So to do that, we have to find our common ratios. What is the common ratio for number 7? Negative 3. Okay, so our common ratio is negative 3. So if I wanted to write the next term, what is 63 times negative 3? Negative 189. What is negative 189 times negative 3? What is 567 times negative 3?
Negative 1,701.
Sophie, breathe.
I'm breathing.
All right, number 8. What is our common ratio for number 8? It is 1/4. Okay, so what would the next term be in this sequence? What is 1/4 of 192? 48. What is 1/4 of 48? Let me at least finish the question
He's
first.
looking out at my calculator. I put it in and he's reading it
No,
off
I
of
knew
my
it was
screen.
I knew it was before she
Stop talking before I finish the question. What is the next term after 12?
3.
All right, now we're going to look at number 9. Okay, what is the common ratio in number 9? It is 1/2. Okay,
Yeah, try and go all fast.
and so what is the next term?
1.
What's the next term after that?
Wait, you're doing fractions?
Yes. What's the next term? All right, number 10. What is our common ratio? So what would the next term be?
Yeah.
Really?
What is the next term?
Negative 625.
Okay, what is the next term?
Yes, I got that.
3,125.
Negative 3,100.
Ooh.
And what is the next term?
Negative 50,625.
Oh my god. Don't blame it.
Okay, so obviously, we can always find terms in a sequence by just multiplying it that many times, right? But would you want to find the 15th term in a sequence by doing that?
No. Wait.
No.
No. Okay, so we can do that by using a formula, and that formula just so happens to be an exponential function. Okay, so we know that we've looked at exponential functions so far, and our formula for an exponential function is the starting point times the ratio to an exponent, right? That's essentially what we're going to do here. So whenever we're trying to find the nth term of a geometric sequence, what we're going to do is we're going to start by saying a sub n. So that just means any term. Okay. Then we are going to say our starting point, a sub 1, times our common ratio to the power of n minus 1. So in order to write this formula, you need to know what the first term is. Okay. You also need to know what your common ratio is. This is similar to the formula we used for arithmetic sequences, but not quite. Okay. But those are the 2 things you need in order to be able to write the formula for a geometric sequence. Okay. The first term, and the ratio. So we're going to actually do some of these. We're going to write the rule for the nth term. So that means we're going to write what a sub n is, okay, or the nth term of the sequence. And then we're going to find a sub 7, so the 7th term of the sequence, okay? So let's start with number 11. What is the first term of number 11? 3. Okay, what is our common ratio for number 11? So we're going to set up our equation. So to find the nth term, we're going to take 3 times 3 to the power of n minus 1. I do recommend you use parentheses here. The reason being, if we have to plug in a negative number right there, having the parentheses ensures the exponents give you the right answer. Okay? Because remember how exponents and negative numbers in the calculator are a little weird?
Yes.
Okay? You have to be careful. So using parentheses kind of helps you avoid that. Now, we have to find the 7th term. So we're going to replace n with 7. So we have 3 times 3 to the power of 7 minus 1. So use your calculator and tell me what 3 times 3...
7.
What did I say about letting me finish the question?
So sorry. I thought that like you were like right there finishing.
Yeah, no.
Where'd you get 7 from?
So we're trying to find the 7th term. It tells us that in the directions. And if I wanted to find the 12th... Shh. Okay. We're crossing the line from funny to disruptive. Okay. Thank you. So if I wanted to find the 12th term, what would I need to plug in instead of 7? 12. If I wanted to find the 52nd term, I would plug in 52. Okay. So now for number 12. Okay. What is our first term? What is our common ratio?
-5.
So to find the equation for any term, we do -4 times -5 to the power of n minus 1.
Why do you have to write that first?
Because it can ask you two different things. It can ask you to write the equation, or it can ask you to find a specific term. So this is how you write the equation. And what we're about to do is finding the term. So in this case, we're finding the 7th term. So we would do -4 times -5 to the 7 minus 1. Okay, so this just gives us the equation. When we plug in, that gives us a specific number. Okay, so what is the 7th term of number 12?
-62,500.
Yeah.
Okay, so now we're going to go ahead and we're going to look at the 13, 15, and 17 on the back. Okay, for question 13, what is our first term?
100.
What is our common ratio?
1/2.
So when we set this up for the generic equation, okay, for any term, I will say what?
400 times 1/2. N minus 1.
All right, now we're going to find the 7th term, so we're going to plug in 7. Once we plug in 7, what do we get? What is it? 25 over 4. When I put that into my calculator, it gave me the decimal equivalent. So if your calculator gives you the answer as a decimal, that's okay. The final answer can be written as either, but I do want your ratio written as a fraction, if we can do that. Number 14, or I said we're not doing that. So number 15. What is our first term in number 15?
-1.
Okay, what is our common ratio?
4.
Okay, so to set this up, it will be -1 times 4 to the power of n minus 1. Then we find our 7th term. What is the 7th term going to be? It's what? Here we go. -4,096. Because I was confused, because when you said 40,000, I was like, wait.
Oh, I know.
Number 17. For number 17, what is our first term?
6.
What is our constant ratio?
-2.
So for our first equation, we get 6 times -2 to the power of n minus 2. And if I want to find the 7th term, I just plug in 7 to get what? 384. Now, I want you to do 16.
That, I don't think that would be right. Because they're the same variable.
Yes.
Can I go for one or one?
Yes. What is the common ratio for 16? It is negative 1/3. Okay. The easiest way to do that is to say negative 243 over 729 using the calculator, the fraction function on your calculator.
I need to say what we have.
You got to go backwards on these. Yeah. And so when we do that, okay, then we set up our equation and we get 729 times negative 1/3 to the n minus 1. Find the seventh term. What is the seventh term? It is 1. See, this is a really good example of why you should use the fraction, not the decimal. Because if you round negative 1/3, you get negative 0.33, right? If you plug in 0.33 to this, you get 9.4. Two completely different things, right? So that's why I want us to try to use the fractions for these. All right, we're gonna look at the word problem at the bottom. So another useful thing that we can do with geometric sequences is we can use them in growth and decay problems where they don't give us the rate, but they give us a list of values. So for instance here, it gives us the values for the first 3 years a car is owned, okay? It doesn't give us the interest rate, it just asks us to find how it depreciates. So it gives us nothing other than a list of values. So if it just gives us a list, we know we can use our geometric sequence. Because it would just be like having 10,000, comma, 8,000, comma, 6,000, comma, and so on. So first, what is the first term that would be in our sequence? If 10,000. Okay, what would the ratio be? Think 8,000 divided by 10,000. If I wanted to write that as a fraction, what would I write? 4 over 5. Mm-hmm. Now, we're going to write our, because it just says write a rule to represent it. So we're going to do the generic. So it'd be 10,000 times 4/5 to the power of n minus 1. For question 20, it asks what will be the value of the car after how many years? So we're going to find the 10th term. So we'll do 10,000 times 4/5 to the 10 minus 1. And what do we get? There we go. So that is geometric sequences. So we are going to do an assignment. It has 4 questions where you determine whether or not it is a geometric sequence, and then it has 6 questions where you have to find the rule, then find whatever term it asks for, right? So I'm going to go ahead and pass them out. And then this morning, all my classes, I'm going to go over at least 1 or 2 of them with them. And my first period, as a joke, we picked 6 and 7. Then second period, as a joke, we picked 6 and 7. Then third period, we just did 6 and 7 because I'd already done it twice. So entirely up to you which questions we do.
6 and 7. Oh, you supposed to wait on me to go?
How do you spell that?
Are we serious? Okay, I don't know.
I still don't know.
February.
It's February.
All right. So questions 1 through 4, you just have to determine whether or not they are a geometric sequence. If it is a geometric sequence, write the common ratio. And I randomly generated them. So yes, it's okay that they're all the same number. Or almost the same number. Okay. Now, we're going to look at question 6 together. Don't look at the answers, please. Okay. For number 6, what is our first term of the sequence? Okay. What is the common ratio? -3. Okay, in here it tells us to write the explicit formula. That is just any term, the formula. So we're going to do the nth term will be 3 times -3 to the power of n minus 1. Then it asks us to find specifically which term. 9. So we're going to plug in 9 for n. So 3 times -3, 9 minus 1. What is that? 19,683. Now we're going to look at question 7.
No, wait, no, go back, please.
Well, if you wouldn't have been talking.
I was not, no, I'm serious, I was talking down, I was regular stuff.
Okay, for number 7, what is our first term? What was the first term? 2. Okay, it just sounded like someone said 6, and I was like, nah.
Okay, go ahead.
Or 7.
Okay, what is the common ratio? Okay, so write your equation and set it up and find the, what term are you looking for? Okay. And what is the 10th term? It is 524,288. Yes. Okay, so I want to briefly talk about our plans for the rest of the unit real fast. So tomorrow we are going to review everything pre-quiz. Okay, we're going to do that with like a classic paper review. Okay, just because I feel like those are the things that we're struggling with the most. On Monday, we're going to do the exponential function half of it by playing a review game. Okay, after the review game, we will actually, I'll upload the PDF of the slides so you can practice them, but we'll do that during class. Okay, so we'll have a 2-part review. Tomorrow it will be the exponent rules, radicals. Then Monday it will be exponential functions. Okay, and all of this stuff can be on the test. Sound good? All right.
For the like explicit formulas, like 5 through 10, will there ever be one where it isn't a common ratio?
No. Because if it's asking you to find the equation of it, it's telling you it's a geometric sequence.